Hi, everybody. Welcome to self-check 4.3 exercises. So for number 6, the function f of x equals 8x to the fourth times ln of x. We want to find the derivative of that. So since we have two functions being multiplied each other and we want to find that derivative, we're going to need to use a product rule. So product rule, recall that it is f g prime plus g f prime. And so you can pick our f and our g. So f would be 8x to the fourth. F prime would be 32x cubed. G would be natural log of x. And so g prime would be 1 over x. Okay, so if we put this all together in our derivative, we would get 8x to the fourth times 1 over x plus natural log of x times 32x cubed. Okay, so then simplifying this out, this x cancels out, this fourth cancels out to become a 3. And what I'm left with is 8x cubed plus 32, just rearranging it, x cubed natural log of x. So to clean this up, one thing I could do is factor out a common term. So they all have x cubed in common, and they both have 8 in common. So we could factor out an 8x cubed and be left with 1 plus 4 natural log of x. And that would be the derivative for this function. Okay, so let's go ahead and try out number 7, which is find the derivative evaluated at 2, f prime of 2, for the function natural log of 2x squared minus 8x minus 2. So in order to find the derivative evaluated at 2, the first thing I got to do is find the derivative of f of x. So the derivative of f of x would be f prime of x equals 1 over 2x squared minus 8x minus 2 times the derivative of that inside. So times the derivative of 2x squared minus 8x minus 2, which would be 4x minus 8. So if we simplify this out, really can't do much. It's just putting this 4x minus 8 on top. And that would be our derivative. But we still need to evaluate it at 2. So this means I need to plug in 2 into this derivative. So f prime of 2 equals 4 times 2 minus 8 over 2 times 2 squared minus 8 times 2 minus 2. So this becomes 8 minus 8 over 8. 2 squared is 4 times 2 is 8 minus 16 minus 2. 8 minus 8 is 0 over 8 minus 16 is negative 8. Negative 8 minus 2 is negative 10. But 0 divided by anything is just 0. So 0 is our answer. So f prime of 2 equals 0. So now number 8 is we want to find the derivative evaluated at 2 again, but for a different function, for natural log of x to the fourth plus 4 squared. So for this, we also need to find the derivative first. So the derivative of this function would be 1 over x to the fourth plus 4 all squared. It's just whatever's inside of this natural log, 1 over that, times the derivative of that inside. So the derivative of this inside is going to be a chain rule. So this would be 2x to the fourth plus 4 times the derivative of that x to the fourth plus 4. So it'll be 5x to the 4. Oh, sorry, 4x to the third. Okay, so then this simplifies out. We could multiply this 2 and 4x cubed. So this would be 8x cubed times x to the fourth plus 4 all over x to the fourth plus 4 squared. And I can cancel out a copy of this x to the fourth plus 4. So what I'm left with is 8x cubed over x to the fourth plus 4. So we still want to evaluate at 2. So I need to plug 2 into this function. So f prime of 2 equals 2 cubed all over 2 to the fourth plus 4. So this is 2 cubed is 8 over 2 to the fourth is 16 plus 4. So this is running out of room a bit. I apologize. 64 over 20, which is 3.2. So f prime of 2 is 3.2, and that's our answer. Okay, so that's for 4.3. Let's go ahead and try out some 4.4 exercises now. So 4.4, we want to find the derivative of this exponential function. So f of x equals e to the 5x squared minus x. I want to find the derivative of that. And so the derivative of anything exponential is going to be itself, the same exact copy, times the derivative of whatever is inside of that exponent. So this would be times the derivative of 5x squared minus x. So this would be times 10x minus 1. And so if we rewrite this, it would be 10x minus 1 times e to the 5x squared minus x. And that's our derivative. Okay, so number 10 now, we want to find the derivative evaluated at 1. So I need to find the derivative of x cubed e to the x. So I need to do the product rule for this. We have two functions multiplying each other, and I need to find their derivative. So product rule is f g prime plus g f prime. So f could be 6x cubed, g is e to the x. So here, f is 6x cubed, f prime is 18x squared, g is e to the x, and the derivative of e to the x is just itself, e to the x. So putting this all together, f prime of x is going to equal 6x cubed times e to the x plus e to the x times 18x squared. And so I want to plug in 1, evaluate this at 1. So f prime of 1 is 6 times 1 cubed. Excuse me, this is a typo. This should be -1. So -1. Let's go ahead and fix that. So -1. So this will be 6 times -1 cubed, e to the -1 plus e to the -1 times 18 -1 squared. Okay, so -1 to the third is -1. So this would be -6 e to the -1. We don't really need to evaluate e to the -1. We're just going to get a really long decimal. So this would be e to the -1. -1 squared is positive, so I'm going to rearrange this a bit. This would be 18 e to the -1. Okay, so now we have a common e to the -1. I can just combine this -6 and 18 and get 12 e to the -1. So our final answer would be f prime of -1 is 12 e to the -1. Okay, so last question, more of an applied problem using our derivative of exponents. So this says a resale value R in dollars of a particular type of laser cutting tool in T years after its initial purchase is approximated by this function. R of T equals 200,000 e to -2.24 T. So what is the decay rate of this resale value? So a rate in this type of exponential function is going to be this right here. That's our rate. So our decay rate is just a -0.24. And it's decaying because it's negative. If it was positive, then it would be an increasing rate, but it's decaying. Okay, so part B, find the rate at which the resale value is changing 20 years after the initial purchase. So the key word here is rate. That means I need to take a derivative. So I need to take a derivative and I want to find the derivative at 20 years. So this 20 years is equals 20. So I'm going to find a derivative and plug in 20. So let's go ahead and check that out. R of T equals 200,000 e to the -0.24 T. So I need to find the derivative of this. So R prime of T is just going to be the same exact thing. The 200,000 comes along because it's just a coefficient, nothing happens to it. So derivative of these exponentials is just going to be the same exact thing times the derivative of the exponent. So times -2.24 T. So that would just be -0.24. So combining this 200,000 and this -0.24, what I end up with is -48,000 e to the -0.24 T. So that's my derivative. And now what I want to do is find my rate at 20 years. So I need to plug in 20 and evaluate the derivative at 20. So R prime of 20 is -48,000 e to the -0.24 times 20. And if I put this in my Desmos, let's go ahead and do that right now. I get -48,000 e to the -0.24 times 20. And I end up with -395.0278. So let's go ahead and round to 2 decimal places. So what I end up with is -395.03. So what this means is that the resale value is decreasing at a rate of $395.03 per year after 20 years. after 20 years of initial purchase. But okay, that is how you would do this problem involving an application trying to find a rate at which something is increasing or decreasing using exponents. Okay, so that's it for this video. I'll see you next time. Thank you. Bye.